Welcome back, mathematicians. In this video, we are going to learn about the sum and difference formulas for sine. So we have these sum and difference formulas so that way we can calculate the exact value of trigonometric functions for angles that are not necessarily part of our common angle group. So what I mean by that is angles that are multiples of 30 degrees, multiples of 45 degrees. So in this case, what we have is the sine of 15 degrees. What we want to do here is break up 15 degrees by taking two angles, multiples of 30 degrees, multiples of 60 degrees, and either add them or subtract them to get 15 degrees. Now, given that 15 degrees is a rather small angle, which is less than 30 degrees and also 45 degrees, I'm going to go ahead and break this up into a difference. So we have 15 degrees is equal to the difference of 45 degrees and 30 degrees. And again, I'm choosing 45 and 30 because I know the exact value when I evaluate sine and cosine of 45 degrees and 30 degrees. So what this means is that sine of 15 degrees is equal to sine of 45 degrees minus 30 degrees, which is equal to, based on the formula above, the sine of 45 degrees times the cosine of 30 degrees minus the cosine of 45 degrees times the sine of 30 degrees. I can now evaluate each of the trigonometric functions for 45 degrees and 30 degrees. So what I get is sine of 45 degrees is equal to square root of 2 over 2. Cosine of 30 degrees is equal to square root of 3 over 2. Cosine of 45 degrees is equal to square root of 2 over 2. And sine of 30 degrees is equal to 1/2. I'm now going to go ahead and find the product of these, and so I have square root of 6 over 4 minus the square root of 2 over 4. I can then rewrite this as one fraction, so square root of 6 minus square root of 2 all over 4. Another problem says if sine of alpha is equal to 1 over square root of 2, and alpha is between pi over 2 and pi, sine of beta is equal to negative 1/3, and beta is between pi and 3 pi over 2, I'd like to find the exact value of sine of alpha plus beta. Now what I know is that the terminal side of alpha is going to lie in quadrant number 2. I know that from the inequality. I know the terminal side of beta will lie in quadrant number 3, and again that's from the inequality. I also know that the sine of alpha plus beta is equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. From the directions above, I already know the exact value of sine of alpha and sine of beta. What I don't know is the cosine of beta and the cosine of alpha. Now to figure those out, what I'd like to do is draw a picture of each of these angles. I'm going to start with alpha. So what I know is that the terminal side of alpha lies in quadrant number 2. I'm going to draw the angle in standard position. I'm going to draw myself a triangle because I know sine of alpha is equal to 1 over square root of 2. This means the opposite side of this triangle is going to be a value of 1, and the hypotenuse or radius will be a square root of 2, which also means the adjacent side has a value of 1. Because we're in quadrant number 2, I'm going to make that a negative 1. Using this triangle, I can now determine the cosine of alpha. The cosine of alpha will be equal to the adjacent side, or x, which is negative 1, over the square root of 2, which is the hypotenuse or radius. I'm going to repeat this process for beta, and what I know is that the terminal side of beta will lie in quadrant number 3. So drawing my angle in standard position and then drawing a triangle, I know that the opposite side is going to have a value of 1. Because I'm in quadrant number 3, that'll be a negative 1. I know that the hypotenuse or radius will be a value of 3. I now need to go ahead and find the adjacent side. I'm going to do that by using the Pythagorean theorem, and what I end up getting is 2 times the square root of 2. Because I am in quadrant number 3, this will be a negative value. From that, I can go ahead and determine the cosine of beta. So the cosine of beta is equal to the adjacent side, or the x coordinate, which is going to be negative 2 times square root of 2, over the radius, which will be 3. I am now able to replace each of the trigonometric functions with their respective exact values. So I know that the sine of alpha is equal to 1 over the square root of 2. I know that the cosine of beta is equal to negative 2 times square root of 2 over 3. I know cosine of alpha is equal to negative 1 over square root of 2, and I know sine of beta is equal to negative 1/3. What I can now do is go ahead and multiply these, and what I end up getting is negative 2 over 3 plus 1 over 3 times square root of 2. I can then rationalize the denominator of the second fraction, and so what I end up getting is negative 2/3 plus square root of 2 over 6. I can then rewrite this with a common denominator, so this will be negative 4 over 6 plus square root of 2 over 6. And then if I'd like to, I could rewrite this as one single fraction, so I'll get negative 4 plus square root of 2 all over 6. All right, guys, good luck.